Hi, and welcome to this session on database design. Today we are going to focus on the entity relationship model. So what is an ER model and why are we talking about it now? Let's get started. Okay, so here is the fundamental idea. Everything in this world can be modeled as a bunch of entities that are related to each other. So here is an example. I teach RDBMS. So Venkatesh is an entity, RDBMS is another entity, and the relationship between these two is the teachers relationship. Similarly, we could find tons of entities being related to each other. Now the idea is to identify these entities and relationships and then convert uh, these bunch of entities and relationship to the relational model. So let's have a look. So before I talk about the entity sets and relationship sets, let me take an example and show you what these are. So here is the instructor entity set. So we call this an entity set where Mozart is an entity. Uh, it has several attributes. So this entity has an ID 15151, the name Mozart, department name, this entity belongs to music department and earns a salary of 40,000. So we say that we have entity sets having multiple entities and their attributes. Um, and we have several such entities, and these entities are related to each other through some relationship. So we say the ER data model employs three basic concepts: the entity sets, the relationship sets, and the attributes. We often represent this diagrammatically by an entity relationship diagram. Uh, so let's go ahead and continue discussing some examples. So here is a graphical representation of a few entity sets. So there is an instructor and there is also a student. So we represent these entity sets as rectangles and the attributes are listed inside the compartments. Uh, the some attributes are underlined and that means that these attributes have uh, the ability to identify the entity in that entity set. So for example, uh, using ID I can uniquely identify an instructor, and similarly using this ID I can uniquely identify a student. Now let's look at an example of a relation. So I have an instructor entity set and I have a student entity set, and the diamonds represent the relationship sets. Now in this relationship set we connect or we relate instructor to student. In this case we have labeled the relationship as advisor. So we want to say that an instructor advises several students, or in other words, students have advisors who are essentially instructors. Often we want to qualify the relationship with the cardinalities. So we could map cardinalities, which introduces constraints on the entity-entity association. So in this case, we say that there is a one is to star, or one instructor may advise multiple students, and multiple students may have the same instructor, or all students have one instructor. That is what we are trying to convey here with a one is to star uh, cardinality mapping. The relationship sets may have attributes, and we denote that with a dotted line. So for example, when an instructor advises a student, there might be a date associated with it. There could be multiple attributes here. For example, there could be a start date, there could be an end date, and so on. So we represent them using dotted lines and rectangles. Sometimes the same entity may participate on both sides of the relationship set. So here is an example. So I have the same course entity set taking the role of a course as well as a prerequisite for that course. So for example, I could have, let's say, history 102 uh, being having a prerequisite of history 101, and I could represent that as follows. There are two ways that we follow usually to represent these entity relationships, and here is one of them. So in this old classical model, we use rectangles to represent the entities and ellipses to represent the attributes. So there is a customer entity who has customer ID, which becomes the key or the identifying attribute, and then we have phone number, date of birth, age, name, and so on as other attributes of customer. Note that some of these attributes could be composite attributes, meaning they can further be broken down into, for example, name can further be broken down into first name, middle name, last name, and so on. And there could be some attributes that could be derived from other attributes, as is evident from this example. Age can be derived from date of birth. We could also have multi-valued attributes. So for example, phone number could take multiple values. The same customer could have multiple phone numbers. So we represent multiple multi-valued attributes with double bordered ellipses. Um, and of course, there is also another way of representing this, which we have been seeing so far, which is using these kind of rectangles for entity sets and diamonds for relationship sets. So this notation um, is more UML like. So if you do not know what UML is, I encourage you to go and look it up. Unified Modeling Language has several useful notations, and this notation kind of follows an UML like style. Um, so you could see both of these notations in many tools. For example, let's try a lucid chart. So if you go to lucidchart.com, let me see if I can open lucidchart.com and share it here. Okay, so I hope you can see my screen now. And here I have a lucid chart, so you could log in. Let's see if you can log in. Yeah, once you log in, you will see several templates, and you see a ER diagram template here. They also provide you with the old style template, which you can look it up here. So if you open the template, you should be able to drag and drop and create a UML style ER diagram here. So let's get back to our slides. So there are two kinds of entity participation. We say total versus partial participation. So here is an example where so let's assume the case where a customer um, acts as a borrower for some loan. So we have an entity customer, we have an entity loan, and we say that so let's say we say that every customer need not borrow. Then we have a partial participation in the borrower relationship. if every loan must have a borrower, we say loan participates totally in this relationship set. So we have total participation, which is denoted using a double line, and a partial participation denoted using a single line. uh, there are entities which do not exist, or which is existentially dependent on another entity. For example, there is no payment without a loan. If that is the case, then we say payment is a weak entity, and payment is always identified along with the loan information. So we need a loan number, and then we need a payment number to uniquely identify the other attributes of payment. Often when you get down to design uh, the database schema, you often have choices. So here is a choice. So let's say I want to model instructor, and let's say instructors have phone numbers. Now, how would you model that instructor? So one way to do that is to design this kind of a schema where I have an instructor entity set with ID, name, salary, and phone number as attributes. I also have another option where I could say that instructor participates in a inst phone relationship with another entity phone, which has phone number, location, and so on. The advantage of designing it this way is that I could have multiple phone numbers associated with instructor, and also it allows me to add additional information about phone. So if phone is a complex entity with multiple attributes, I would rather prefer this way of designing the schema rather uh, than choosing this way of doing it. So if you become a database designer or DB architect, the first thing that you usually do is to come up with a ER model for the underlying domain for which you want to design the database. And once you have the ER model, then you are interested in converting or reducing that ER model to a set of schemas. So now we will focus on how we could convert an existing ER model to a schema. Uh, okay, so here is a quiz. For the ER models given, what do you think uh, would be the suggested schema? Uh, in the first case, I have a course and I have a weak entity section. Section is identified by section ID, semester, and year, and we say that, and of course, there's a the relationship set in which the weak entity participate is represented using a double diamond as shown here, and we have labeled this relationship as SEC under course underscore scope course. So how would this convert into a relational schema? So let's take a look. Sorry for the delay. I'm just trying to set up my pen so that I can write on the slides. All right. So here is one way to convert this to a schema. So let's say there is a course table and we have course ID, we have title, and we have credits. For example, So let's say I have RDBMS 101. That's, let's say, the course ID. The title is RDBMS, and let's say there are 4 credits for this course. I can have another entity IR. The title is also IR, and let's say it has 4 credits too. So the table may look like this, and the way we could convert this course table is to a table is as shown here. Now, what about the section information? So I have a section. So one way to do that is, let's say, section ID, semester, and year. But do you see a problem now? Since section is a weak entity, section does not exist without course. So a way to identify a section is along with the course ID. So we go ahead and add course ID as well to section table. So this is one way of converting this ER model to a relationship structure. There is also another way we could design the schema. So we could have course uh, with the same these 3 attributes, and we could have section with these 3 attributes, and then we could have a sec course table which has course ID and section ID, right? So we could have uh, the course table, we could have section table, and we have the sec course table. So with these 3 tables I could still model this. So there are 2 ways to model this. Which one would you prefer? Well, if uh, if I don't have a star to star, many to many relationship, then this way of modeling is perhaps sufficient. But if course IDs and section IDs are many to many related, then would probably prefer this way of doing it. So let's take another example. So instructor and student related through advisor. In this case, you see that both instructor and student are strong entities. So strong entities translate to an independent table. So we'll have an instructor table, and we will also have a student table, and we would have the ID, name, salary columns here, and here we would have ID, name, and total credit columns here. And I can simply have so here I'm assuming that the relationship is 1 is to star, in which case I could have one instructor could have multiple students assigned to him, or he might be advising multiple students. So here is a question for you. Where would you, what would you do to capture this relationship? One option is to add student ID to instructor, or another option is to add instructor ID to student table. Which one do you prefer and why? Pause the video here and take take a think. If you had said instructor ID in the student table, that is correct, because every student has a single instructor as advisor. So it makes a lot of sense to have instructor ID in the student table. On the contrary, if you put a student ID in instructor table, we'll have to repeat the instructor rows multiple times, and that would cause redundancy. Okay, so we have discussed this. So let me skip these slides. Now, if an ER model is given like this, then how would this translate to a schema? Well, by now I hope you have already figured this out. We will of course have all the strong entities converting into a table. So instructor becomes an instructor table with the same columns mentioned here, and we also have a student table with the columns mentioned here. So we have three columns each, and since advisor has an attribute, we create an advisor table, and we could have instructor ID, we could have a student ID, and we could have a date. Now there is also another option. In the student table, along with the instructor ID, I could also have a date. So these are two different ways of modeling the same thing, and both of them should equally work, and depending on the nature of the mapping cardinalities, we decide which one to follow. Okay, so here is another quiz for you. How many minimum number of tables are needed to represent this ER model? So you see that a strong entity M gets converted into a table M, and we have another strong entity P, so it has its table P. And now I have a weak entity N, and I have to decide what to do with this. I know that N has N1 and N2 attributes, but then N is identified through the primary key of P, which is the identifying attribute here is P1. So N is identified as P1, N1, N2. So we have N, and we have P captured here, and we have M captured here. The only thing we haven't discussed is the R1, in which M participates totally. So since M is a total participation on P, so we would like to have P1 added to M. So three tables are sufficient to capture this ER model. What to do with composite attributes? Well, we usually flatten them into the structure. So this kind of composite attribute design would translate to a table like this. So where we have instructor ID, first name is a column, middle initial is a column, last name is another column, street number, street name, apartment number, and so on. So just all these are flattened, and they represent columns in our new schema. Okay, so here is a wake-up quiz for you. An entity relationship diagram is a tool to represent which one of the below: data model, process model, event model, or customer model. And I hope you know the answer already. It represents a data model. So we want to capture the data as relational structures, and the first step to doing that is to do the ER diagram, and from the ER diagram we convert or we reduce the ER diagram to table structures. That's all for today. Thanks for being with me. Hope the idea of ER modeling is now clear to you. Thank you.